guys, welcome back to another video on my YouTube channel. Today I will be solving some past paper questions on longitudinal waves, so let's get started. Today I will be solving question 6 part A and B from the May-June 2021 session, paper 4 variant 1. Figure 6.1 is a full-scale diagram that represents a sound wave traveling in air. On figure 6.1, mark 2 points, each at the center of a different compression. Label both of the points C. Alright, we know that the compression in a longitudinal wave is at the point where the wavefronts or wavelines are closest together or are compressed together. Therefore, we can mark a C over here and here. You can also mark it on the compression on the left side if you want. Part B states that the speed of sound in air is 330 meters per second. Measure the diagram and determine the frequency of the sound. Alright, first let's recall the formula. Frequency is equal to 1 divided by time of one wave cycle. But over here, we don't have the time, so we could use the other formula. Frequency is equal to wave speed divided by wavelength. To get the wavelength, we have to measure the distance between two compressions, as that's one wave cycle. We have to measure this off the diagram, which is 5.2 centimeters or 0.052 meters. The measurement won't be correct on your screen as the scale is different on the paper. Next, input the values in the equation and then add it into your calculator to get 6,300 Hz rounded to two significant figures as your final answer. That will be the end of our question. Please like and subscribe for more videos like this, and if you have any doubts, feel free to comment them down below. I'll be glad to answer.